Hello, my dear students. Once again, welcome to your online class. So today, in this video, we'll be learning about the ninth chapter of your chemistry textbook, that is the chapter Ammonia. Okay, so this also comes under the topic, the study of the compounds. So in the previous video, we have studied about the hydrogen chloride gas, and in this video, we'll be discussing about ammonia. So in the reduced syllabus, mostly we have the topic related to the laboratory preparation of ammonia and the industrial preparation of ammonia, which is known as a Haber's process. So in this video, we'll be studying in details about the laboratory preparation of ammonia and as well as the Haber's process. So to begin with the chapter ammonia, so we know that the ammonia, it occurs both in free state and as well as in a combined state. And apart from that, there are four different forms of ammonia, namely the gaseous ammonia, which is a dry gas. Then we have a liquid ammonia, which is the liquefied dry gas or the liquefied ammonia. And the third, we have the liquor ammonia fortis, which is a saturated solution of ammonia with water. And it's also called 880 ammonia. And lastly, we have the laboratory bench reagent. This is the dilute solution of liquor ammonia, which is used in the laboratory as a reagent. So now coming to the laboratory preparation of ammonia. In laboratory, the ammonia is produced by heating a mixture of ammonium chloride and a calcium hydroxide. So here I have drawn a figure that explains the laboratory preparation of ammonia. We see that a round bottom flask is taken in a tilted position. So now comes the question, why a tilted position? It's because when the ammonium chloride is heated with a calcium hydroxide, one of the byproducts produced is also the water. So if this water trickles back into the heated round bottom flask, it may crack. So that's why it is taken in a tilted position. Okay, so then after the ammonia in the round bottom flask, a mixture of calcium hydroxide and ammonium chloride is taken and then heated. When heated, it liberates a moist ammonia gas. So this moist ammonia gas is passed through a drying tower that contains a quicklime or which is also a calcium hydroxide. So what does this tower do? This tower absorbs the moisture present in the ammonia gas, and then we obtain the dry ammonia gas in this way. So the reaction proceeds as the ammonium chloride, when treated with the calcium hydroxide, it gives the calcium chloride, water and the ammonia gas. So this is how the ammonia is produced in the laboratory. So during this laboratory preparation of ammonia, the higher ratio of weight of alkali is used so that it may counter the loss by the sublimation of ammonium chloride. Although the ammonium salt on heating with the alkali, it gives ammonia, but the salts like the ammonium nitrite is not used to produce ammonia. It is because when heated, they decompose to produce the nitrogen dioxide and water. Apart from this, it can also be prepared from the metal nitrides like magnesium or the aluminum. But this method is not preferred as this method is costly. Since ammonia plays a very great role in the preparation of fertilizers, so producing ammonia in a less quantity in the lab is not just sufficient. So the ammonia is required to be produced in a very large scale, which is known as the industrial preparation of ammonia. So in this process, what is done? The mixture of nitrogen and a hydrogen gas in the ratio 1 is to 3 is taken, and then it is passed to the compressor, which compresses the gas and it also mixes the gas. So once it is compressed, it is passed through a tower known as a catalytic chamber. So in this catalytic chamber, there is a catalyst like iron. Okay, so the iron is taken as the catalyst and molybdenum as a promoter. So in this catalytic chamber, all the reaction takes place. And this catalytic chamber is maintained at a constant temperature of about 500 degrees centigrade and also at a 250 atmospheric pressure. So once it is compressed and heated, the reaction occurring is the ammonia when treated with a hydrogen in the presence of iron and molybdenum, it gives ammonia. Okay, at around the temperature it is 500 degrees centigrade and 250 atmospheric pressure. And then thus we obtain the ammonia gas. Okay, so if I need to balance, I'll put there 2, and then I'll write here 3. So now the ammonia gas coming out from the catalytic chamber is very hot. So in order to cool it down, what is done? It is passed to the next tower or the next chamber, which is a cooling chamber. So thus here the ammonia is cooled, and then finally we obtain the liquid ammonia. So this process is also known as a Haber's process, after the name of the person who discovered this process. Since this reaction is highly exothermic reaction, so what happens? The low temperature, it favors the forward reaction. And also, since the full volume of the reactant produces only 2 volumes of the product, so therefore the high pressure favors the formation of ammonia. And finally, the catalyst and the promoter, what does it do? They speed up the reaction. So dear students, these are the two important topics included in this chapter. And apart from this, you will also read the reactions of ammonia with various other acids, and as well as there is a fountain experiment and the uses of ammonia. So please go through your books in detail, and if you have any problem, you are always free to ask me in my WhatsApp number. Thank you.